All right, last class we started talking about the structure of an atom, so I'm going to do a quick review. We looked at carbon atom last, and we said that there are neutrons and protons housed in the center of an atom in the area called the nucleus. So right here is going to be our nucleus. Our protons are going to be positively charged, and our neutrons are neutral in charge or have no charge. Surrounding is going to be the electron cloud, and this is where our electrons reside. So here is an electron and here is an electron. We differentiated between two types of electrons. We looked at inner electrons, and then we described the outermost electrons as valence electrons. So if we look at our carbon atom, we should have 6 protons, 6 neutrons, and 6 electrons. And if we're only looking at valence electrons, our carbon atom has 1, 2, 3, 4 valence electrons. So now that we've looked at the structure of an atom, we can go ahead and discuss element. So we've talked about element before, and we've said it's a pure substance because it contains entirely of one atom. So for our carbon element, it's entirely made up of carbon atoms. Even when we talk about our diatomic elements, even though those exist in pairs of 2 in nature, they're still only made up of one kind of atom. So for example, our diatomic elements include hydrogen, oxygen, fluorine, nitrogen, bromine, iodine, and chlorine. If we consider oxygen out in the world, it's going to be O2. Even though there's 2 elements or 2 atoms, they're still the same kind of atom. They're still both oxygen atoms, so it's still considered a pure substance or an element. Elements also cannot be broken down or made, and they're represented by these 3 different things on the periodic table. So first, they can be represented by their symbol, and this is going to be 1 or 2 letters. So for carbon, our symbol is actually just going to be C. If we think about elements such as cobalt, it's represented by a capital C, lowercase o. So that second letter must be lowercase, and that's super important because if we think about having a capital C and a capital O, that's going to be carbon and oxygen rather than cobalt. So just be careful of that whenever you are differentiating the symbols for different elements. We can also represent our element by its atomic number. Each element has its own atomic number, and this is on the periodic table as a whole number. So this will be 1, 2, 3, 4, 5, 6, and so on. This indicates the number of protons of an element. So carbon has an atomic number of 6, which means it also has 6 protons. The atomic number and the number of protons for a given element can never, ever change. So if I were to add a proton, that would entirely change the element. If I were to take away a proton, that would change an element. Therefore, for a given element, you must always have the same number of atomic number and protons. So the number of electrons may or may not also equal to this atomic number. It will be the same if your element is neutral. So anything that you grab off of the periodic table is going to be a neutral element. Therefore, you should have the same number of protons and the same number of electrons. Because if we think about protons, they have a positive charge. So we can imagine this as having a plus 6. Our electrons have a negative charge, so we can imagine this as a minus 6. Plus 6 minus 6 gives you an overall or a net charge of 0. Therefore, that would be neutral. So an element without a charge, if there were a charge, you would see one here, but an element without a charge is going to be neutral. Therefore, you should have the same number of protons and electrons. Your atomic mass is going to be the last piece of information that we can find on the periodic table, and that's going to be, it tends to be a number with a longer decimal. It's a decimal and it's not very nice because it's actually a weighted average mass of an element. So even though on the periodic table there's only one carbon element, carbon actually exists in more than one form, and they each have a different mass. The mass that we put on the periodic table is actually an average mass of all of these existing forms of carbon. And so we're actually going to talk about a term called mass number, and a lot of people get confused with mass number and atomic mass. For atomic mass, it's really important that you say it's a weighted average mass of an element. So this atomic mass also gives us a little bit more information. We can figure out the number of neutrons from this number because our atomic mass equals to protons plus neutrons. We already said for a given element, its protons is always going to be the atomic number. So we know protons is 6. So 6 plus neutrons equals to an atomic mass of 12. We can round that number. So that means that 6 protons plus 6 neutrons would equal 12. Here we have oxygen, and I just got this from the periodic table. If we look here, we can tell that the symbol is going to be an O, and we also are able to identify the atomic number, protons, electrons, neutrons, and atomic mass. So our atomic number is always going to be a whole number, so in this case our atomic number is 8. Remember, your atomic number is always going to equal to the number of protons. Therefore, we must have 8 protons in oxygen. Now this is also going to be a neutral element. We know this because this is straight off of the periodic table. Any element right off the periodic table is going to be neutral. We can also look in the top right corner. There is no charge on oxygen, so therefore we also know that it's neutral. So if it's neutral, then the number of protons must equal the number of electrons. So therefore, if we have 8 protons, then we know that oxygen in its neutral state has 8 electrons. Now we can also look at the atomic mass. Now we can round this mass to 16. So your atomic mass is going to be the weighted average mass, and it's going to be of our protons plus our neutrons. So if our protons is 8, what must our neutrons be in order to give us a sum of 16? If we think about it, our neutrons also has to be 8. So 8 protons plus 8 neutrons would give us a total atomic mass of 16. Now it doesn't always work out being 8 protons, 8 electrons, and 8 neutrons, but in this case it does happen to work out that way. Let's look at one more example. So if we look here, we're given a Bohr model that tells us that we have 7 protons, 7 neutrons, and 7 electrons. First, we're asked to identify the atomic number. So the atomic number is always going to equal to the number of protons. Remember, we can't change the number of protons for a given element. Therefore, if we have 7 protons, then our atomic number must also equal to 7. Our atomic mass is going to be our weighted average mass, and remember that's going to be our protons plus our neutrons. Therefore, if we have 7 protons and 7 neutrons, then our atomic mass must equal to 14. Now, if we look on the periodic table and we look for an element with an atomic number of 7, you should come across the element nitrogen. And if we also look at nitrogen, you can look at its atomic mass, and it should be around 14.007, which is very, very close to our 7 protons plus 7 neutrons, which equals to 14. And so therefore, our element is going to be nitrogen, and the symbol representing nitrogen is going to be N. Go ahead and take out your booklet from last class. Today we're going to be adding a little bit more information. Last class in your first tile you should have defined an atom, and we also ended up drawing an example of the carbon atom structure. So today we're going to be defining an element and going over some of those terms that we just discussed. So on the outside of your booklet in the second tile, go ahead and write element, and go ahead and include its definition right below. So I wrote that it's a pure substance and it's made up of only one kind of atom. I've also added that it cannot be broken down any further, and I've included some examples. So I have carbon, cobalt, and the diatomic element oxygen or O2. If you go ahead and open up your booklet, on the left-hand inside of your booklet, we're going to define some of those terms we just discussed. Our first term is going to be our atomic number. Your atomic number is always going to equal to your number of protons. Now remember, for any given element, the atomic number and the number of protons are never going to change. It's always going to be the same for a specific element. Our atomic number is also going to equal to our number of electrons only if that element is neutral. So if we pull it right off of the periodic table, that is going to be a neutral element. Therefore, you would expect the same number of protons and the same number of electrons. Our second term that we're going to define is going to be a symbol. This one is a little self-explanatory, but our symbol is going to be made up of one or two letters, and if there are two letters, then the second letter is always going to be lowercase. Lastly, our final term is going to be the atomic mass. The important thing about your atomic mass is this is the weighted average mass of an element. So go ahead and underline or highlight whatever you need to remember that your atomic mass is the weighted average mass. This average mass or atomic mass ends up equaling to our protons plus our neutrons. Therefore, if we have the atomic mass and we have the protons from the atomic number, then we're able to solve and find for the number of neutrons of any given element. Lastly, on the right hand side, you're going to include an image of our carbon element as it is seen on the periodic table. So this is just off of the periodic table, and we can kind of see that it's written on top, carbon element, and we also see right below there is the atomic number. So the atomic number is going to be 6, and therefore the number of protons is also going to be 6. This is a neutral element. It is right off of the periodic table, so it should also have 6 electrons. Our symbol is represented right here. Our symbol for carbon is going to be C. And then finally, our atomic mass is going to be 12.011. So our atomic mass is going to be a weighted average mass of all of the existing carbons, and it also is going to equal to our protons plus our neutrons. So if we know that carbon has 6 protons, and we know that its atomic mass is 12, then we can also find that its number of neutrons is going to be 6, because 6 protons plus 6 neutrons would give us an atomic mass of 12. So each of you guys should have received a handout titled Adopt an Element. You will be creating an advertisement for a specific assigned element. You should have received an email outlining which element you specifically will be doing. For your advertisement, you must include all of these things in the bold. So it's atomic number, atomic mass, symbol, and etc. A really good resource I use is going to be webelements.com, but you can also use your notes, your PowerPoints, the periodic table. But this website, if you look on the side, it does have each of the elements and you can go ahead and click on it. So the element I did was hydrogen, and if you look over here under more properties, you can click its physical properties or you can look at its uses. You can also see its group number, its period name. So this is a really good resource for you to use. So in your advertisement, if you look down here on the second page or the back sheet, it does have a fact sheet. This is going to be a good guide for you as you're creating your advertisement, so you just follow through and include the name, the symbol, the number, and so on. At the bottom, just make sure you include which resources you are going to be using in your research as you're looking up all of these things for your element. I've also included an example of the advertisement that I am kind of expecting from you guys. So the resource I used to make this advertisement is going to be canva.com. And here's the ad I made for hydrogen. Now you don't have to use Canva, you don't have to use an online resource. You can hand draw it and you can hand write it. I just want it to be colorful and exciting, so whichever preference you have, that is a-okay with me. But I just went ahead and did it online because I thought it would be easier. If you look at this advertisement, you can see that I've included the atomic number, the symbol, the atomic mass, its properties, its position on the periodic table. I've also included a Bohr model, which you could look up. Just make sure you include the proton, the neutrons, and the number of electrons for that specific element. I've also included the uses of hydrogen, and as you're creating your slogan, think about your uses and how you can tie it in. So, hydrogen is going to be part of water, which is absolutely essential for life. It's also going to be a part of rocket fuel. So, in my slogan, I have fueling life on Earth and fueling the discovery of life beyond. So, just be creative in your advertisement, follow the instructions, and then make sure you submit this onto On Campus. There is an online submission, and this will be due at the end of Monday. Okay, good luck and let me know if you have any questions. I'll be happy to help you and have a good weekend.